Basics of structural analysis. So, what is, first of all, structure? What is a structure? A structure is something which supports load, and how it supports load. Suppose this is a structure and there are two loads are acting on it. Maybe some kind of swing on this portal frame. There are two loads, I suppose they are acting on this structure. So how the structure is transferring these loads to the ground, and with the deformation of it's within limit, so that nobody will be get injured because of its failure. So this is a science. Basically it requires basic knowledge of calculus, basic knowledge of algebra, mathematics in general, and the basics of mechanics like vector additions and their applications, and in structural analysis we just evaluate how the structure is transferring the load. What happens to these members which are transferring these loads? They get deformed, and their deformation is also analyzed, also studied in the subject named as strength of material. How the material get deformed, get failed. Maybe it's because of crushing, maybe because of some twisting of it, maybe because of some shearing. So there is a other domain of structural engineering, and I am starting this series, Basics of Structural Analysis, to give you some idea about what is this subject is all about, and maybe you will find it helpful the way I explain my these concepts and in my style. So this is a structure, yeah, and this is transferring these loads. So we must understand some things, that a body say a body, it is resting on a ground, and I assume that it is a frictionless, and if it is frictional, it is rough. In reality, no object is absolutely frictionless, and when it is frictionless, the both surface get welded each other. They get in so much good addition in between them. So I assume they are in rough. So if they are rough, whenever the load act on them in horizontal direction, there will be some frictional force. Say this is small f. If this is, say, force F, this F is a frictional resistance, and it depends on the amount of normal. And what is normal? If it is a load, say it is load due to gravity, it's a weight of it. which is equals to the mass of it multiply the local acceleration due to gravity. And this is supported on the ground very well. So it is getting some reaction which is generally called as normal reaction to the weight. So if force is not strong enough to cross the barrier of this frictional resistance, this object will be in rest in relative frame to the observer. So if observer is also not moving, then you can see that. So it is static. Static means that it is not moving. So what is equilibrium? It is a two-dimensional structure. I am considering it is in two dimension. Say it is x and this is y direction. There are two directions, x and y. Those are coordinate to just study the position of this object. So how mechanics is how the mechanics is going on. So we should see, we are saying that this object is not moving in x direction, neither it is moving on y direction. It means all these forces W and this small f, this capital F, are in balance state, and those state of balancing these forces is equilibrium state. What is that? Equilibrium. So equilibrium along the x-axis, I'm talking about in two dimension, don't forget that, because in 3D there will be some more forces, some more forces about z-axis. Yes, so there will be some different statement for that, but for this case right now I am taking the equilibrium of the system along x-axis, and I can say that these forces along the x-axis, which is F force, equilibrium of forces, I am writing it as summation along x direction. The sum of all forces along x direction should be 0. It means if I am taking this is positive F, because it is acting in the direction of x, then a force which is F, I am assuming that it is also acting on the centroid of this object. I am assuming it to simplify my analysis. So there will be some small f, and none of the other force has either component in the direction of x. All the component of W and N is 0 in the x direction, because it is acting right angle to the x, and the component which will be cos of that angle, and this is 90-degree angle, then cos of 90, which is 0. That's why you don't get a component of W along the direction of x. So this will equals to 0, and I can say that F is equals to small f if this structure is in static state. all the force which I am applying to push this object, I assume that I am applying, and this frictional resistance, both are equal. That's why it is not moving. And the object is also not moving along the y direction. I say it is my first equation of equilibrium equations. I should write it. Equilibrium equations. I'm not good at writing spellings. Sorry for that. English is not my mother tongue. Okay, so equilibrium equation. First this one. Second equation is summation of forces along the y direction. It also equals to 0. So I'm saying that this was in positive. I just show you what is, and this is in this direction. I am taking it as positive. Then what should be my application of this equation to this case? In this case will be n is acting in the positive direction of it, and w, which is acting in the negative direction, must be equals to the 0. And what it implies? N equals to W. All the reaction I'm getting is because of all the load, or they say its self weight, or because of this. So what happens if N is not adequate to support W? Suppose W is 10 kilonewton and N can be offered up to say 7 kilonewton. Then the remaining 3 kilonewton will be unbalanced, and that unbalanced force will move this object in the direction along it, the resultant direction. So that happens when somebody is in wetlands. I mean, I don't know what to say it in English. I don't know what is the correct vocabulary for that, but it is some kind of mud, and it is too wet, and when some object is here, it will sink. Object keep on sinking due to its own weight. So what happens there? There is a net force which is not balanced out, makes this object to follow the direction of gravity. So this is another equilibrium equation. See, look at this object which we are talking about. One more thing, we can see this object is in 2D, but we know that this object is also have some dimension which is perpendicular to this page. I assume it is not a rocket, it is just a pen. So that direction, I assume it's Z. Since this object is also not rotating like this, you see, I'm rotating it is not rotating. So the rotation of it, I assume that I apply the right hand thumb rule, then this rotation I assume it is z in this direction, and rotation for that, which you saw, say I use another variable m. It is a moment, so I used another variable m, and the moment is about z-axis, which I can observe in the 2D because my xy plane is rotating about it, and that z-axis could be anywhere. I can put it here. If it is here, then object is not moving about it. If it is in the center of it, the object is not rotating about this center. So that is the thing, and the equilibrium equation will be equals to all the moment acting in this direction must be balanced out, otherwise it must be moving object. If it is a structure, it must not rotate. It is supposed to take load. It must be stable. If it is a mechanism, then it should be controlled. Its motion must be within control limit. You must have seen some doors in buses and in trains, that or escalators and all. Those structures have some mechanism ongoing on them, so they are also in equilibrium. And whenever equilibrium gets disturbed, it balances it just by introducing some pseudo forces like centrifugal and centripetal force, inertia force, to balance it. But that is not we do not study in structural analysis. We study that in structural dynamics. So let's get to the point, back to the point, and I was talking about moment and moment about the z-axis. I assume that it is z-axis rotation. It is the rotation along the z-axis. So that moment I assume that z-axis is pointing outward, and so the rotation according to my right hand is in anti-clockwise direction. So it is in anti-clockwise direction, and this equilibrium I am showing here. And since there is no if all these forces are acting on the centroid of this object, then there must not be any moment. If they are acting over it, all forces are concurrent, then there will be no such force to create a moment about it. And in that case, I can say all the moment is, if there is some forces, then that will be eccentrically acting on it, then that will be balanced out by that forces, or directly by the rotation. See this case. This is a cantilever beam. It can support a vertical reaction, it can support a horizontal reaction. You cannot pull this beam out of the support. It will resist, and it won't get down because this is a fixed. So this will get a reaction, this will get a reaction, and one more thing is also not rotating about this direction. It is not rotating. So it is not rotating. It means that it is also getting some support reaction to not get rotate. So this is a support reaction. I write it as mz. Maybe it is a support I give a notation to it. This node I am saying that it is A, this node is B, then mz at B, you can say like this, something like this. You can use notation mz at B, and usually people write it as mz at A, and people find it difficult to write. It is lengthy, so, and especially when you are using it in so many times in your calculations, then people say it is just a MA, yeah, to simplify the calculations and to reduce the time for it. But for that, we should not forget what this moment is all about and how it came into. We need to visualize. We are making a structure. We have to visualize the thing in reality. So we have to imagine, and that is a vertical reaction. I say it is Fx, and that is also on A. This is F. Oh, this is Y. Sorry, I mistake. I did mistake. Sorry for that. And Fx. So this is a structure. It can support a vertical load, it can support a horizontal load. It is not moving, it is a stable. And one more thing, it can it is offering a rotation, so you can apply a rotation on it and it will resist it. And not only this rotation, if you apply, this rotation can be caused because of this load is acting at some distance from it. You can say this is a L length, and this force is this load is P, then P times L will be a moment, even though when this moment M is not present or not present, then M and plus PL will be the combined moment which will be offered in reaction by the support, which will be equal to mz. Then we can say mz equals to PL times we can write taking by sign convention. This could be positive clockwise, this is negative, so we can say mz is mz plus mz minus PL minus this is M. So that will be our reaction of moment. It is easy when we have only 3 support reactions to evaluate, because we have 3 equilibrium equations. These three equilibrium equations can solve 3 variables, 3 unknowns. We can get 3 unknowns out of it. If you are not getting my point, I should show you some example. Say I ask you x plus 9 equals to say 11. Then what is the value of x? Yeah, it is easy, man. It must be 2. X should be equals to 2. Oh man, x equals to 2. It's easy. It is not a difficult question. Oh, I should give you another question then. A plus b plus 9 equals to 11. And now tell me the value of a. you can tell loop, because you have to say, you can say a number because it is also variable here. You can say just it will be 2 minus b, and 2 minus b, it is not, it will be a number, but right now it is not a number. And that is the problem when we get structure with support reactions more than 3. We have 3 equilibrium equations for this 2D problem, and we are having here, say, 1, 2, 3, 4, 5 and 6 support reactions. We need 3 more equations, and that the requirement that 3 more is the indeterminacy of this structure, and specifically it is static indeterminacy. That will be, and that I will tell you more about that in another video. So hope you like it. It is all about equilibrium equations and what is a structure, and I hope you like it. If you like it, then hit the like button. Okay, thanks for watching.